Hi and welcome. So imagine you're a customer support agent and you get a really complex query. How great it would be if you could just have access to a vast knowledge base, and that would help you provide a tailored answer to that query. This is exactly what we're going to be looking at today. So we'll be building RAG, Retrieval-Augmented Generation, a system using BigQuery and Gemini. And for added points, this system will work entirely serverless. So this system will be built for internal users, so the users within your company, and they will be able to ask and receive answers from your data using just plain language, meaning asking a question, receiving the answer. So a somewhat similar approach to Gemini or ChatGPT, only it is using your data in quite a clever way. So let's see how this solution will work once we are done with it. So this is basically our simple front end. I used, for this demonstration, we will use a public dataset on BigQuery that contains BBC articles from early 2000s. It's not an ideal use case because we're looking at business use cases here, but it is easy enough to answer, and I think it's good to start because we can just fetch it with a query within BigQuery, as I will show later. And also, it is we can still prove that it is using this data, not just the data from whatever the large language model Gemini was trained on. So in this example that we're looking at, so the user would ask, "What is internet?" and so in the white box below, there is an answer that is generated by Gemini based on our data, on the data from the BBC articles, and it tells you nicely, so based on the data from the BBC articles, broadband internet is always on, fast connection was changing the way people use the internet in the UK as of 2005. So you can clearly see, this is not the answer that a large language model would give by itself. It is data that is based on the data that was inputted, so from the BBC articles from that period. Now, for added value, because this can also prove useful, we will also show the user the search results below, so they can also see the data that was actually inputted into Gemini. So because the process is, we'll first search the knowledge base, and then we will select the data that's most relevant, send it to Gemini, and then it will generate the answers based on just that data. Use cases for a system like this, as I mentioned, this is for internal users because BigQuery is just not built for concurrency, it's not built for speed, it's an analytical database. And this is great when dealing with large amounts of data, but it is intended for, it's not intended for 1,000 users to use concurrently or something like that. You would need a different solution, different database for that. But here it is useful for in-house, so company employees to use this data. So there's a general knowledge base it can be used, so whatever knowledge you have accumulated, it's very easy to access this way. User support tickets, as I mentioned, so you have a query from a user and it will help you solve it, provided that you have your knowledge base contains data that can help with this situation. Onboarding, so you have a new employee, and they're asking a lot of questions, and you can point them here, and they will ask the questions, and they will get them from this RAG system. It also helps when browsing the documentation, so you can get answers from the documentation easier if you don't have already a very good system to browse it. It can happen a lot that systems are not that good. And it also helps with stuff like tenders, meaning that, tenders, the process when you're applying for tenders can be, there can be a lot of knowledge included, a lot of people, and a lot of, distillation of answers, and, whatever helps here, it can be very useful. The RAG, Retrieval-Augmented Generation system. So what's the point of it? What's the difference between this and Gemini or ChatGPT? We are doing a two-step solution. So in ChatGPT, you could, or you probably have already, sent some company data in and just ask it to give an answer based on that data. You can do that, right? So those large language models and with the context windows expanding, they are getting increasingly better at this. But with the RAG, with this system, it is a two-step process. And first, you want to browse and find the data that is most useful for answering the query you have. Meaning you could have like, thousands or 10,000s or millions of entries of for example, past user support tickets. And we want to build a system that will like select like just like 5 or 10 of them, like the ones that are deemed to be most similar to the question asked. And then we just send those to Gemini and it generates answer based on those, for example, 5 queries. This is a lot faster, a lot cheaper. And, in some cases, if you have like a really, really lot of data, this is the only way to do it. In our example with the BBC articles, I think there were like, there are a few thousand articles, I think, in the database. And, you can't really, it doesn't make sense to send them all for each query. You want to like first identify those who will help best and then send just those. And this is what we will do. So the design for our solution, as I mentioned, this is end-to-end, meaning that we will build a simple front end. We will build and the back end, which contains of multiple parts. So the flow basically is user writes the question. So they put this into a website, sends, click send. We call the cloud function. We will use Google Cloud Functions with Python for this solution. And this cloud function then sends the query to BigQuery, gets the answers back, then sends those answers to Gemini. Gemini generates the answer like from a natural language answer to those questions, containing the question and the responses from BigQuery. It will construct a natural language answer, and then it will nicely return this in a form of a nice JSON to the front end, where this will be shown to the user. This is an AI or machine learning solution. So we will be interacting with two models here, two types of models. You don't need to be concerned with this because we are not doing training. So we are this is a solution in the post-training era, if you want. So we are interacting with those pre-trained models as basically just as APIs. So we are sending some input we're sending some data into them, we're getting some data out, and then we're using this data. And the first model that we're using is an embedding model. So what does this do? So I will explain this in more depth later, but essentially it takes human readable text and assigns it some numerical values. So what we will see is like some arrays of floats, or essentially vectors. And we need those vectors to do the search. For what I mentioned before, we want to search similar terms, and of course you can just do this with text. We need to translate this into numbers and run through this to do a similarity search. I will touch on this more later. But it is not something that you should be too concerned. You don't need to really understand how this works. So, don't let this stop you from building such a system. And the second model that we'll be using is a generative model, Gemini in our case. And how this works, we'll send some human readable text and we'll get some human readable answer. So this is basically how you interact with Gemini or ChatGPT products, right? High level, we need to enable and perform the vector search. So we need to do this search to see which terms are similar, so we can identify those 5 best data points, and we will send the knowledge base entries, and we will send those knowledge base entries to Gemini and generate answers based on those. So second step is we are sending this data to Gemini. Third step is setting up a REST API endpoint to wrap this all together and then just design the simple front end. So the BigQuery part. So first we need to add an embedding model to BigQuery. I will show you like briefly how to do this. Add a column vector, add a column with vector embeddings, and then perform the actual vector search within BigQuery. So this is quite interesting that you can do this all in within BigQuery, and this is why it's a very simple way to do it, and this is why we're relying on it to do our vector search here. So adding an embedding model is basically like creating a table or anything else in BigQuery, create or replace model. So here we specify the name of the model. So where do we want this model to live in our BigQuery data set? But we're not actually copying anything there. We're just doing a remote with connection call, meaning that we'll basically be just, when referring to this model, we'll just be passing, this is just linking to a model that lives in Vertex AI, so another of the Google solutions. And we're basically just connecting a bridge to that Vertex AI model. And this is basically the 3 lines of code that you need to add the model to your data set. And it looks something like this. So, it lives under your data set, models, text embedding, for example. The second step is we need to add a column with vector embeddings. So this is perhaps probably the most complicated part of this all, but you don't really need to, I'm just gonna explain it so you have some basic intuition what's going on here, but don't get, scared of it or anything. So what we're doing here is we're taking the data, as I said before, from BigQuery, public data, BBC News, full text. So this is the database we're using for this example. So this is the BBC articles I referred to before. And we're specifying, okay, I want 2 columns from this table, and then I want to use the model that I created before. So the STUS text embedding, I'm going to use this model. And I need to specify some other parameters, like I want to focus on semantic similarity. So because we're doing a similarity search, right, we're looking at how similar the terms are. When we will be searching on how similar the terms are when we're performing search. So these are essentially the parameters the query you need to run to create a table with the vector embeddings. It looks something like this once you run it. So content on the right hand side, content and title. So this is what we were looking at before, right? This is something we also showed to the user. And on the left hand side, we have generated embeddings, which is just this, this is just a lot of numbers, essentially a list of floats, if you want, or a vector. So I will just briefly touch. So just so you're not, it's a weird thing to see in BigQuery if you're not used to it. So I'll just really briefly try and explain this, or at least give you some intuition on how these, vectors came to be. So imagine you have words like king, man, woman, apple, banana, orange, football, golf, tennis. If you're looking for which words are similar between those, you need to do something with it, right? You can't just match parts of words and say, oh, okay, because they all start with an A or something, not a good way to do it. So what we're doing is we're using an embedding model, which will put all those words or all those terms or sentences into they will assign vectors to them. So these numbers we see on the right, and these numbers position this word somewhere in a space, right? And this is illustrated on the most right hand side. So you can see that like king, man, woman, they're all together. They're similarly positioned. And again, football, golf, tennis, similarly positioned. Apple, banana, orange, similarly positioned, because they were assigned numbers that represent how close those terms are in some in some space. And here we can draw this nicely, because this is a 2D example. And as we can see here, this is like, I think these are like 700 dimensions here, but for our case, it doesn't really matter. This is just, I'm just showing this for intuition. So if you can imagine, they can just take, so when we'll do a search, we'll just take all those numbers, and like we can see in this simplified example here, if I'm searching, for example, for orange, it will know that apple is like a really close match, and it will return, for example, apple as a top result, apple and banana, because I searched for orange, because it will know that these are similar. And this would be the same, for example, if your user has a problem with, logging in, it will return the login answers, first, and, not bother with, for example, pricing or something like that that has nothing to do with it, but it will find similar entries and just send those few entries to Gemini and generate an answer. In the last step, we need to perform the vector search. So again, nothing, nothing too wild here. I haven't mentioned, but all this code is available on the GitHub. So this is like just excerpts, so you can have some intuition about what we're doing. Basically what we are doing, so for example, the question here, the user's question here would be, what did it say about Slovenia? So, I'm asking what did BBC articles of that time say about like this country, Slovenia. And what you also need to keep in mind is that, we are doing the search on these vectors, on these numbers that I showed before. And so whatever you enter, you need to do the embedding on the fly with every answer, with every question that the user asks. You need to embed it before doing a search, because of course, if you think about it, like even with examples that I shown before, like king, queen, you can't compare king to a bunch of vectors. You need to embed it first, right? So you need to put it in the same space, and you're searching within this space. Why is this important? Well, this is why we had to put like a model in BigQuery, and we will be referencing it on the fly, right? So every time you do another query, you need to first embed the question. So that's why it's important that your model, embedding model, is not that far away from not that removed from your production system. Because if you're doing this offline, you could just use some model, do this once, and then just save to BigQuery the vector representations. But we need to be more mindful and have the model ready and be able to really quickly do the embedding again and again and again for every search that is made. So basically, we're doing selection of top 5 most similar results based on the user query, with a query resembling something like this. The result of this query then is like ranked search results, 1 to 5. What did it say about Slovenia? So we can see that Slovenia wasn't mentioned. It didn't find any match. For some reason, it went for Slovakia as the first result. Second one is perhaps more interesting, when we can see that terms in here include Croatia and Yugoslavia, and geographically and historically, so Slovenia used to be a part of Yugoslavia. So apparently there is some connection there. It put it in context and found that Yugoslavia is somewhat closely related to Slovenia, and it returned this answer to us. Croatia is a neighboring country, so perhaps this also played a part. But this is essentially, so our search will work like this, right? So we're doing a similarity search, similar terms pop up, and for example, these 5 are, I think, quite good. In our case, I would hope that the large language model will tell us, there's nothing about Slovenia. But this would be like the best candidates from our data base, from our knowledge base on that topic. And we can see that, if we were searching Slovenia with like a regular search, it would just return nothing. And here it always will return 5 closest results. And, in some cases, it can be very interesting, because if you're just doing like matching strings, you will never get Yugoslavia out of Slovenia, but using our system, you can. So the API and the Gemini part. So the API that we're designing basically puts in a user query. So what is Slovenia would be the user query. Top number would be the number of results we want to get, and the output is Gemini response, search results, title, content. So let's just look at this in here. So if you're familiar with Postman, so this is the what we're sending into our endpoint, user query, and the number of results we want. And below we will get the answer, so what was generated from Gemini, and we will also get the search results that we can then show to the user, right? And they are shown as a list, of course, because we want to return the list of 5 results here. as I mentioned, we will be using, for this, we're using Google Cloud Functions. And the important parts here are the get data from BigQuery. This is the query I've shown before, right? Where we take this, who is George Bush, for example, and we embed it, create a search, and get the data from BigQuery. We also then want to generate a response from Gemini, where we send these results from BigQuery and send it to Gemini, and then we just like nicely format this API response and return a JSON like this, right? And then we show this on the front end. To briefly also touch what's going on. So when we're interacting with Gemini, how are we prompting this? So you need to essentially provide a system instruction. So this is there's a more complete version on GitHub. This is like a simplified version where just to fit on the screen basically. But what you want to do is like put a system instruction. So you are helping with summarization of articles. And the prompt is like what you're actually, this is what you would perhaps ask Gemini or ChatGPT, and you just say, tell us more about, and we pass in Python here the user query. So who is George Bush, for example, in the last example, based solely on the data from BBC articles, and then we will. In this case, I'm just passing just a Python list because it doesn't really matter to these models. It doesn't need to be formatted. They actually work really well with just JSON. Or like just really nicely structured objects. I found that they actually work better than, in plain text. Then we specify which model do we want to use. So temperature, how creative do we want it to be with our answer, pass in the system instruction that we defined before, and then we call Gemini and we want it to return the text. So this is it from how we're building this. And let's just then now look at our solution, how it actually works. So this is the end result of our of this end-to-end approach to RAG, Retrieval-Augmented Generation, using BigQuery and Gemini. So here I can perhaps ask, who is Tony Blair, who was the UK's prime minister in the era that those articles are covering. So I click now send. The data is first embedded. So this question is embedded. It's sent to BigQuery. BigQuery does the semantic similarity search. It returns like the top 5 results, which we specified. It then sends those 5 results to Gemini, and the Gemini sends the data back along with the 5 articles in the database that it finds that are most similar to this. And the result we got was Tony Blair was the Prime Minister of the United Kingdom. He served as the leader, was the longest service Prime Minister, Labour Prime Minister as of 2005. Yeah, okay. So you can see that, it is time limited, the question. Okay, so we can just check Iraq war. So how do you know about the Iraq war? Yeah, you see that, it is referencing stuff that is coming up from these articles. This is basically it, right? So we ask a question here, it calls our system directly. So we can try another one. So how good was Half-Life 2, for example? This is a game that again came out in about that era. Based on data, Half-Life was critically acclaimed first-person shooter that garnered significant praise for immersive, stunning graphics. And we can see that the articles from here that is referencing. Again, this is not the best example in the world because Gemini will know some stuff about what we're asking here, so we just need to be paying really close attention that it's really just considering what was passed in and not the knowledge it was trained on, which is hard to distinguish in this case a bit. But it is quite, it is good. It is good enough example. It was easy to do. And if you imagine your user queries or something like this, it will give you Gemini will not know that stuff that you're passing in if it's from inside of your company, and you can really then play around with this and see how well it does with queries, like for example, customer support queries and so forth. So thank you for watching this video. There is a Medium article that also takes you through the whole process and the GitHub, so you can get started and start with this end-to-end example, implement it, I believe, quite quickly. You will have to enable a lot of permissions and stuff that I didn't touch here, but you know, that's security in in the 21st century for you. But that's essentially it. I hope it helps you. I encourage you to try it, to build it out, to see how well it works for your use case. And good luck innovating with AI systems like this. So thank you.